All right, guys, just a rundown of section 1.4. So this is very brief, and I can't wait till we start going into more proof. But section 1.4 is just an introduction of theorems, and a theorem is just a mathematical statement that can be proved. Okay, so we can prove every single theorem. I won't do that to you, but we are going to prove some of them. And underneath this, I have two examples of our first theorems. So this is up to you guys on how you guys want to organize your notes. I would recommend kind of having a running list of your theorems on a separate page or a separate section of your binder. If you want, that way you can just refer back to all of the theorems. Your book actually in the back, I forget what page, 700 and something, has all the theorems listed. So I understand if you don't want to copy them, but writing something down just kind of helps it stick in your brain. So theorems most of the time are very well, that's obvious, right? Like if I'm standing in the rain, then I will be getting wet. It's very obvious. And that's what theorems are a lot of the time. So I know it starts to sound overwhelming, like I have to memorize these, but it just makes sense. So your first theorem is if two angles are right angles, then they are congruent. And your second theorem is if two angles are straight angles, then they are congruent. Okay, you are now allowed to use any of these to prove anything that you want. So you're allowed to use those theorems. We're going to write a sample two-column proof. When you write a two-column proof, you're going to have two columns, okay? The first column is going to be called your statements, and the second column is going to be called your reasons. Okay, so your statements and your reasons. You're always going to be given some kind of information, and you're always going to be asked to prove something. So we are going to number our statement, the first statement, and we usually start by looking at our givens. So I am going to put down diagram because they gave us this beautiful diagram. So I am telling the reader to look at the diagram, and that was given to me. I don't need any explanation, okay? The next thing I like to do is I like to take a look at what they're trying to get me to prove. So they're trying to get me to prove that angle ABC, so that's this angle, is congruent to angle DBE, this angle. Okay, so those angles are congruent to each other. That's what they're trying to get at. So do I know anything about angle ABC? I sure do. Angle ABC is a straight angle. Okay, that's my statement. I'm telling you, hey, I know that angle ABC is a straight angle. Well, how did I know that? Because I can assume that, assumed from diagram. Okay, in these reasons, we're allowed to put theorems, definitions, postulates, which we'll get there, and our assumption list that we just went over in section 1.3. So I can actually assume that angle ABC is a straight angle. Okay, so do I know anything about angle DBE? I sure do. Angle DBE is a straight angle. And how did I know that? The same as number 2, assumed from diagrams. And you are allowed to put that. And then the last thing, I now know that because ABC is straight and DBE is straight, and I go back to theorem 2, I can say angle ABC is congruent to angle DBE. I can prove that. I promise I know that for sure. And how do I know that? Because if two angles are straight angles, then they are congruent. And I proved that they were straight angles because you can tell from the diagram that they're straight angles. So that was kind of an example of our first proof. I do want to do a restrictions problem with you guys because I'm giving you guys those on homework. So a lot of times when we're talking about the restrictions, when you guys are doing your homework problems, if you guys are good with this, you guys can cut the video here. But I know I'm going to be getting a lot of questions on the restrictions type of problems. So if I said, for example, that you had in obtuse, that's an A, obtuse angle, that was, I don't know, 2y plus 24. And I said, what are the restrictions on y? So the first thing we have to ask ourselves is, what is an obtuse angle, right? So an obtuse angle is when the angle, I'm going to call this theta, is in between 90, but it has to be less than 180, because if it was equal to 180, that means it'd be a straight angle. And if it was equal to 90, that means it would be a right angle. So this angle right here, I'm calling it theta. That's a theta. You guys will see that in sororities and fraternities. Theta, it's a Greek letter used to represent a given measurement, angle measurement. So we know that our angle has to be in between 90 and 180, okay? So they're telling us that our angle is 2y plus 24. There's an obtuse angle that's 2y plus 24. What are the restrictions on y? So I'm just going to plug in there the 2y plus 24, and now this becomes a compound inequality. Compound inequality. So if you want to look your notes up from freshman year in honors algebra, you should have used compound inequalities. Subtract 24 from both sides. Not both sides, all three sides. Okay, this becomes 0. 90 minus 24, what is that, 66. I still have a 2y here. And then 180, 156. Divide everything by 2. And what I'm left with is 33 is less than y, which is less than 78. Again, doing the math in your head, I was just trying to do this really quick. I split it up into 150 and 6 divided by 2 because I knew that 150 divided by 2 is 75, and 6 divided by 2 was 3, and that's how I got to that 78 right there. So that is the restrictions on y. Y has to be bigger than 33, but less than 78. So again, if you plugged, for example, 79 in for y, your angle would be too large, and it wouldn't work. So that's why 79 doesn't work. And so your restrictions on y, it has to be in between 33 and 78 in order for it to be an obtuse angle. Thanks for watching, and we will do 1.5 next.